Hello my dear students, welcome back to Learn Physics. In today's video, we are going to continue with the kinematics portion. Last class we were discussing about the graph exercise questions. So in today's video, rest of the exercise questions we will be discussing. Those who didn't watch the previous videos, please watch. For the past 3 weeks, 3 days we were discussing about the graph questions only, and today is the last video for about the graphs. Okay, so last class we discussed 10 questions. The rest of the questions today we will be doing. A particle projected vertically upwards returns to the ground in time t. Which graph represents the correct variation of velocity against time? So here some of the graphs are given. So we need to find out when we are throwing an projected vertically upwards. So we are throwing an object upward direction. What will happen? Initially the object will be having some velocity, and when it is moving upward direction, velocity is decreasing. Then when we are considering the downward motion, what will happen? Velocity will be slowly increasing in the opposite direction. Okay, so in time capital T, it is reaching to the ground. So how can we draw that diagram? See here, for this we can draw the velocity time graph for that situation. So velocity I am drawing in the y-axis, time along the x-axis. Initially it will be having some velocity. So initial velocity is present here, and then velocity is decreasing, coming to 0, and then when the velocity become equal to 0, it is in the maximum height. It is at the maximum height. So when it start moving in the downward direction, what will happen? Velocity decreasing and coming to negative direction. At time t, it will be velocity becomes maximum in the downward direction. So negative direction also. So this is the graph which is which we are getting for this. So the same line graph is given A. A is the A option, and as many other graphs are given. It's not required, right? So we need only this graph. Next one, the velocity time graph of a body is shown in figure. It implies that at the point B, so velocity time graph is given like, see V, and this is the portion A, here it is B, and again here it is C. It implies that at point B, now options are given. 0 at point B, velocity is 0. There is a force towards the motion. There is a force which opposes the motion. There is only gravitational force. Okay, so here which is only gravitational force, is equal, this velocity is equal to 0 at B. So that is not, anyway it's not possible. Velocity is changing over here. It's changing uniformly, decreasing with respect to time as time increases at the portion B. So this is the B pole. This is represented as B. So velocity is decreasing with as time increases. What is happening to velocity? Velocity is decreasing. Okay, as time increases, velocity is decreasing. Velocity decreases with respect to time. Then what about the acceleration? Acceleration will be negative. That is, retardation is happening over there. Retardation means the force is acting against the motion, right? So there is a force which opposes the motion. So for negative acceleration means in the opposite direction. Okay, if the force is acting in the forward direction, there's acceleration in the backward direction, negative direction. So here the answer comes like, there is a force which opposes the motion. Before that, force is acting towards the motion. Towards the motion means it will be C. At the point A, the portion A, velocity force is equal to 0 over there. Right, because velocity is a constant, so acceleration is 0. Velocity is constant till this time, so it is here acceleration is 0, so velocity is equal, so force is equal to 0. Now here it is velocity is decreasing, that is retardation is happening against motion. Then here it is increasing, then it is in the same direction. Applied force and the motion are in the same direction. Okay, so here the answer is there is a force which opposes the motion. Next one, the velocity time graph is shown in figure. For a particle, the acceleration of the particle we should find out. Velocity meter per second, and here it's 15, from 15 till 3. This is 3. We need to find from the velocity time graph. How can we find out the acceleration? Slope of the graph will give you acceleration. Slope means, see here, slope of dy by dx. So acceleration equals dv by dt. What is the change which is happening? 15 divided by 3. So it is 5 meter per second. Now here it is, velocity is decreasing with respect to time. So acceleration will be negative. So 0 minus final velocity minus initial velocity. So 0 minus 15, that is minus 15 divided by 3. So minus 5 meter per second square. Clear? Next one. The velocity time plot of a moving object is shown in figure. The average velocity of the object during the first 10 seconds is. So velocity time graph is given. Here velocity in meter per second, here it is time, here it is given like increasing, decreasing, and then going like this. Here it is 0, 5, here it is 10, here 5, this is minus 5. So what we need to find out? Average velocity of the object during the first 10 seconds. Velocity time graph, we need to find out the average velocity. To find out the average velocity, how can we average velocity? What is the formula? Average velocity equals total displacement divided by total time. What will be the total displacement over here? Displacement, how can we find out? It's area under the graph. This is positive and this will be 0 to 5, and here height is 5. Here also 5 to 10, so time is 5 only, height is 5. Right? So, but this is in the positive direction. So, same value we will be getting, but both are in the opposite direction. So, what will be the displacement which is happening over there? Displacement will be equal to 0. Therefore, average velocity also we will be getting it as 0. No need to calculate because positive, negative. Instead of that, if the displacement is asked, we can find out the average speed. Means we can find out the what is that total distance covered. We can add up and do. But here total displacement means total displacement will be equal to 0. Therefore, average velocity also will be equal to 0. Clear? Next one. Which of the following graphs cannot possibly represent one-dimensional motion of a particle? So the graph is everything as position time. No. Total displacement. Here it is total distance covered. Here it is distance covered divided by time. It is given like increasing, then like this, then increasing, then like this, again increasing. And next one, next position time graph is here position time graph, it is given like this. Next one, it is given like, velocity time graph. Here it is velocity and this is time. So it's like this. And another graph is given like, fourth one I'll draw here. Okay. It's here decreasing, then increasing, this one. From here we should identify which is the one-dimensional motion. So first, this was the first one. So increasing, so till here it's okay. After that what is happening? Velocity is, distance is decreasing. That means it's not under not in a straight line motion, not in uniform motion. It's one dimensional motion. Here position at the same time different positions, that is not applicable. Here also at the same time different position, that is not applicable. This one, see here velocity speed is coming to, it is decreasing and coming here, and then speed is becoming negative. So when it is coming to negative, this also not possible. So here it is, this is not possible, here it's not possible, this also not. For all the four are not possible as an one-dimensional motion. Clear? So the next one, If the velocity v of a particle moving along a straight line decreases linearly with its displacement s from 20 meter per second to a value approaching 0 at s equals 30 meter, then acceleration of the particle at v equals 10 meter s. So here the graph is given like here in s in meters, here velocity in meter per second, here 20, and here it is given like 30. So till here s in meters, velocity in meter per second. Read the question once more. If the velocity of a particle moving along a straight line decreases linearly with a displacement s from 20 meter per second to a value approaching 0 at s is equal to 30 second. Okay, 30 meter. Then acceleration of the particle at v equals 10 meter s. So v in 10 meter per second. When velocity equals 10 meter per second, what will be the acceleration? Acceleration, how we can find out? Here velocity is given and distance also given. Okay, how can we find out? Acceleration equals dv by dt. This one we know. Right? Now I am going to do, see, I am going to multiply and divide with the ds. ds by dt into dv by ds. Okay, so what is ds by dt? Is the velocity. Velocity into how the dv by ds is changing. Velocity and distance are changing it as 20 to 30. Right? Maximum change is 20 and here displacement change is happening for 30. Velocity, we need to find out the 10 meter per second. So 10 into, this is the rate which is acceleration is happening, right? Not acceleration, rate of change in velocity with respect to ds is given. So 20 by 30, here 20 by 30, 20 by 3, 20 by 3. And here one more thing we need to consider, that it is velocity is decreasing with respect to time. So it is negative, minus 20 by 3 meter per second. So this approximation you should know. dv by dt we can multiply and divide by ds. So here if you are doing many questions relating to the same kind, it will click to you very fast. Okay, ds by dt and dv by dt. ds by dt is v. So in this rate only displacement is changing with respect to velocity. Okay, as velocity changes, displacement is happening in this way. So we 20 by 30, that is velocity is decreasing, therefore it is negative minus 20 by 30 into 10. So here we will get it as minus 20 by 3 meter per second. Okay, next question. V square versus S graph of a particle moving in a straight line is shown in figure. From the graph, some conclusions are drawn. Which statement is wrong? We need to identify the wrong statement. Here S and this is V square. Okay, V square versus S graph of a particle moving in a straight line. V square S graph is given. So here this is velocity, initial velocity is present. At that time displacement is equal to 0. Displacement is 0 when you were present. Okay. Now the given graph shows a uniformly accelerated motion. V is proportional to S. Then we can write it as V square minus U square equals 2AS. V square minus U square equals 2AS. So here it is V square minus U square. See, it is directly proportional to S. So it is under accelerated motion only. This graph is obeying accelerated motion. But U square is present. Right here, and the second option is, so that is not a wrong statement. Next is initial velocity of the particle is 0. So whether the initial velocity is 0? No, its initial velocity is present over there, right? So initial velocity is not equal to 0, therefore that is a wrong statement. Corresponding to ST graph will be like a parabola. ST graph will be parabola because V square and S is given. So with respect as time increases, along with that displacement is yes, it is moving with the is moving as a parabola. It's uniform accelerated motion. ST graph will be a parabola. None of the above, that is wrong. And so the initial velocity of the particle is 0. Next question. The area under acceleration time graph gives. Tell me what is area under acceleration time graph? Will give you change in velocity. Area under the acceleration time graph will give you change in velocity. So 2 more questions are there. So that they are also of same kind. So I think today's video is useful for you. Many graph questions we discussed. So all these will be useful for you, I guess. And if you have any suggestion, please send it in the comment box. Okay, and in next class we will be studying about the relative motion, relative velocity, relative acceleration, that and all we will be studying. So and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.